Hi, welcome. I'm going to introduce you to the Hifisonix KX2 Class A amplifier. One of the features of this amplifier is that you can switch between Class A, Class AAB and Class AB operation. So in Class A operation, the amplifier current draws around 1.2 amps per channel, 2.4 amps total, and in Class AAB around 600 milliamps per channel, and in Class AB around 160 milliamps per channel. The KX2 amplifier is a current feedback amplifier. Of course, the other popular topology that's used in audio power amplifiers is the VFA, or voltage feedback amplifier. CFAs typically feature wide bandwidths and fast rise fall times, and one of the defining characteristics of this topology, of course, is they don't slew rate limit. So it's better to talk about rise fall time with a CFA amplifier. This amplifier it can be set up for two compensation modes: standard Miller compensation, which is a pole splitting technique, and the other mode is transitional Miller compensation, or TMC, a technique that was discovered or invented by Baxandall and later independently invented by Edmund Stewart. And you can read about that if you root around on DIYaudio.com. There's a discussion about this technique. You can select between the two compensation modes, i.e. Miller compensation and transitional Miller compensation, or TMC, using a jumper on the PC board. Now, in Miller compensation, the loop bandwidth is around 1 kilohertz and the loop gain at 1 kilohertz is around 63 dB. With transitional Miller compensation, the loop bandwidth is a shade over 20 kilohertz and the loop gain at 20 kilohertz is around 57 dB. The result of this is that you have a dramatic reduction in HF distortion on the amplifier, because with TMC you're extracting an extra 20 or 25 dB of loop gain at HF. So with Miller compensation, the loop gain is around 30 to 35 dB. And with Miller compensation, it's very close to 60 dB. So there's a big increase in the available loop gain to reduce distortion. And how you typically measure this is, if you measure the distortion at 1 kilohertz between the two compensation modes, you actually see very little difference in the distortion, because the loop gains at 1 kilohertz are around about the same. However, if you do an IMD test with a 19 kilohertz plus 20 kilohertz stimulus, and you look at the 1 kilohertz intermodulation product, you will see that that drops by about 15 dB or more with TMC, and that, of course, is because you have this dramatically higher loop gain at HF. A quick word of warning: you may be tempted to put a switch across the jumper that selects between the Miller compensation and transitional Miller compensation to be able to switch between the modes. I honestly don't recommend you do that. The compensation feedback point consists of HF components, and you don't want those to be messed with because of wiring inductances and things like that. You will probably create problems if you do that. So just use the jumper, either select one mode or the other. Some people prefer Miller compensation because they believe the distortion profile is more natural, but that's for you to decide when you build the amplifier and listen to it. You decide what you want to do and insert or leave the jumper as appropriate. Each channel of the amplifier is built on a compact through-hole plated PC board. There are a few SMD components on there, mainly decoupling capacitors, but the rest of the components are through-hole mount. A lot of attention was paid to the layout of this amplifier, the PC board layout, to ensure that the noise floor was as low as practicable. For the power supply, you can either use the standard basic power supply that's supplied by Jim's Audio, or you can use this power supply here, which is a ripple eater power supply. So this is a rectifier plus smoothing capacitors, and then you have a ripple eater on the output, which lowers the ripple on the supply rails amplifier, giving you an even lower noise floor than you would with the basic power. Special attention was paid in the front end layout of the amplifier to reduce the loop areas. And as a result, the noise floor for the most part sits below minus 120 dBr, reference 15 watt RMS out. That's very, very quiet. You have a bit of a noise 50 hertz noise spike at about minus 110 dBr, and then at 100 hertz and 150 hertz you've got one at about 118 dBr, but the rest of the noise floor is below minus 120 dBr. So it's a very quiet amplifier. You won't hear any hum or anything like that if you put your ear next to the speaker, provided of course you wire the amplifier up correctly and as shown in the presentation that's on the website describing the amplifier. If you look at the underside of the PC board, you'll see that white silk screen there, and that basically is a wire that you've got to track, just a thin single core wire that you track that follows that line around, and basically what that's doing is taking the feedback resistors through to the input side of the hum breaking resistor, and that wire will track the 0 volt wire or 0 volt trace on the board to keep the loop area to an absolute minimum. And of course that's one of the big things that allow this amplifier noise floor to be reduced to the levels that you see in the specs. Supply rails of the amplifier for the 15 watt RMS rated output, A class A, are 28 to 29 volts. Of course, if you're a little bit higher or a little bit lower than that, that's okay. The amplifier will still perform well. It will still work and deliver about 10 watts RMS out with plus minus 22 volt rails. If your rails are above, say, 30 or 31 volts, it is not recommended that you operate the amplifier in Class A, but instead operate it in Class AAB or Class AB, and that's because the dissipation, of course, then is quite high. The output stage consists of 2 pairs of output devices, and this has been done, of course, to spread the heat out and reduce the thermal stress on the output devices. So the amplifier will be very reliable once mounted, and of course if you're using a decent sized heat sinks, but don't push it. Don't try and run in Class A at excessively high voltages. You really will need more output pairs to do that and have a reliable and high performance amplifier. So the output standing current on the KX2 amplifier is controlled with a single transistor, so it's directly regulated, unlike some Class A amplifiers that rely on thermal feedback. So typically it's the kind of technique you'd use in a Class AB amplifier, where you set the standing current and then you sense the temperature in the output devices and the drivers and control the quiescent current in the output stage using that thermal feedback. With this amplifier, it's a single transistor that simply measures the current across the output degeneration resistors in the output stage and controls the bias to the output stage to maintain that current constant. To switch between the different modes, on my particular iteration of this amplifier, I've just mounted a small toggle switch underneath the amplifier near the front panel, so I can actually switch between the modes over here like this. For the power supply transformer, I recommend you use a transformer of 250 to 350 VA. Don't be tempted to cut corners and use a transformer at the rated power of the amplifier, i.e. 120 watts, which is the full load dissipation in Class A, because you will run into temperature problems and you could have mechanical noise problems running a small transformer like that at full load. Remember, with a Class A amplifier, you're drawing high powers off the transformer, and any noise problems in the transformer will be manifest just without even an input signal. You don't have it in Class AB amplifiers because the current draw with low level signals or no signal is low, and when the music's playing, of course, the noise is masked by the audio, by the signal coming out the speakers. Class A amplifiers, you've got to take extra care with the power supply design to ensure that you don't run into any of those problems. If you build the KX2 amplifier, you will need a substantial housing. The standing dissipation is around about 120 watts, so that means your heat sinks are going to typically be about 1.5 kilograms per channel. You don't want to use smaller heat sinks than that because the temperature rise will be quite high, and you want to limit the maximum temperature on the heat sinks to around about 55 or 60 degrees and no higher than that. That's a brief introduction to the Hifisonix KX2 amplifier. I hope you liked this video. If you have any questions, please feel free to just post them up here on YouTube underneath, or better still, visit the Hifisonix homepage for the KX2 amplifier. The link is underneath this video as well. You can pick up a presentation there of about 40 or 50 pages that describes the circuit, gives the measurements of the amplifier, and tells you how to assemble it and wire it up. There's also a very nice thread on DIYaudio.com that talks about the KX2 amplifier. And by the way, there's lots of other nice stuff on DIYaudio.com from all sorts of other designers. So if you're interested in audio, that's a fantastic website to go and look at. I think there's about 500,000 members. Many threads discussing all sorts of wonderful audio stuff. Anyway, thanks for watching, and see you around.